Hey everyone, and welcome to Study with Pro Dudu. Today we're going to dive into a topic that's all around us, every single day, chance. We're going to peel back the curtain on the mathematics of uncertainty, and I promise it's not as scary as it sounds.
Think about it. From the moment you wake up, you're dealing with uncertainty. Should I bring an umbrella? Is my team going to win the game? Life is just full of these little questions, right? We're always kind of guessing what might happen next. But what if there was a way to measure those guesses?
Well, there is, and that's exactly what probability is for. It's this amazing tool that lets us take that fuzzy feeling of, I think so, and turn it into a solid number. It's basically the science of chance.
Okay, so before we can start calculating anything, we've got to learn the lingo. Just like learning a new language, probability has a few key words we need to get down first. So let's use a really simple example to get our heads around it.
First up, we have the word experiment. Now, don't let that word intimidate you. In probability, it just means any action where we don't know the exact result ahead of time. The big things are that we can do it over and over, and we know all the possible things that could happen. Our experiment for today? Just rolling a regular old six-sided die.
So once we do our experiment, we get an outcome. An outcome is just a single, specific result. So if we roll that die and it lands with a 4 facing up, well, that 4 is our outcome. Easy enough, right? Next up is the sample space. This sounds fancy, but it's just the complete list of every single possible outcome. For our die roll, the sample space, which we usually just call S, is the set of numbers 1, 2, 3, 4, 5, and 6. That's it. Nothing else can happen when you roll a standard die. And our last vocabulary word is event. The event is the specific thing we actually care about, the thing we want to measure. It's a group of outcomes from our sample space. So if our question is, what's the chance of rolling an even number, then our event, which we can call E, is the set of even numbers from our die, 2, 4, and 6.
All right, we've got the language down. Experiment, outcome, sample space, and event. You got this. Now let's get to the main event. How do we actually calculate the probability?
Okay, here's the magic formula. Now, it might look a little formal, but the idea is actually super intuitive. All it's saying is that the probability of something happening is the number of ways you can get what you want divided by the total number of things that could happen. It's just a fraction, the part you care about over the whole thing. So let's use this with our die rolling example. Step 1, how many outcomes are in our event, rolling an even number? Well, our set was 2, 4, 6, so that's 3 outcomes. Step 2, what's the total number of outcomes in our sample space? That's 6. Step 3, we just put those numbers into our formula. The probability is 3 divided by 6.
And the math is pretty simple from there. 3 divided by 6 is the same as 1/2 or 0.5. That means you have a 50% chance of rolling an even number. See? We just took an uncertain situation and put a precise number on it.
Now, I'm going to let you in on a really cool trick, a powerful shortcut that can save you a ton of work. Sometimes, figuring out the probability of what you want is really complicated, but figuring out the probability of what you don't want is super easy. And that's exactly where the complement rule comes in handy.
Just look at this example. Imagine we want to know the probability of getting at least one head if we flip a coin 4 times. If you look on the left, you can see that's a lot of different possibilities to count up, 15 of them to be exact. But look at the right. The opposite of getting at least one head is getting 0 heads. And there's only one way for that to happen, getting tails every single time.
So here's the rule that makes this so powerful. In any experiment, an event either happens or it doesn't. There's no in between. So their probabilities have to add up to 1, or 100%. That means if we find the probability of the easy thing, the complement, we can just subtract it from 1 to get the probability of the complicated thing we actually wanted in the first place.
Let's watch it work. First, we find the probability of our simple complement, getting no heads. There's only one way for that to happen, TTT, out of 16 total possible outcomes when you flip 4 coins. So its probability is 1/16. Then we just do 1 minus 1/16 and we get 15 sixteenths. Boom! So much faster than trying to count all 15 possibilities.
So, we've been playing with coins and dice, which is great for learning the basics. But you might be thinking, okay, Prof. Dudu, why does this actually matter? Well, it turns out these simple ideas are the building blocks for some of the most important tools in science, technology, and business.
I mean, really, this stuff is everywhere.
When scientists test a new medicine, they're using probability. When insurance companies figure out your car insurance rate, they're using probability. All those financial models on Wall Street, the statistics you see on the news, even the stuff that keeps your computer secure, it all comes back to these core ideas. What we've learned today is literally the first step into the huge world of data science.
And that's a wrap for this lesson. We started with some pretty basic questions, but we ended up with the foundation for how we understand our world. The big takeaway is that probability isn't just for math class. It's a new way of thinking. It gives you a new lens to see everything, from the weather report to a sports game. Thanks for studying with me today. If this helped you out, don't forget to hit like, share this with a friend, and subscribe to Study with Prof. Dudu. And make sure to ring that notification bell so you don't miss our next explainer. See you next time.